There's never been a better time to be building the future. Better connectivity technology that can scale to the entire planet, bringing billions of people online to a faster internet. Nothing in the world is advancing as fast as AI is today. And it's helping us build entirely new computing platforms. From VR headsets to AR glasses. These new platforms will help us share truly immersive experiences and reimagine what it's like to be together, even when we're physically apart. Transforming how we work, play, and connect with the people we care most about. We build these new platforms and technologies with privacy and safety baked in from the very beginning. And it's all being invented here, inside the lab.
I'm Neil McGuire, and I'm a VP of Engineering for Facebook Connectivity. I've been at Facebook since 2012, and I actually helped launch Facebook's connectivity efforts back in 2013. It's been exciting to see all the progress we've made since then, and the variety of technologies we've developed to help connect the world and bridge the digital divide. As Karthik mentioned, fiber is great because it has a bandwidth thousands of times greater than any other connectivity technology. But bringing fiber connections to the last few hundred meters, where people are in homes and buildings, what we call the last mile, is one of connectivity's biggest challenges. In an ideal future, everyone would have fiber to their home or place of work, but that's not the reality we're in today. Just 17% of households today have fiber to the home, and I'm sure there's many of you who are joining us today without a fiber connection. While this is the average for the world, looking at developing countries across Africa and parts of Asia, we see this closer to 4%. It's really low. With things like zoning, permitting, and traffic disruption making it extremely challenging to lay fiber, this is especially true in urban environments where trenching fiber can be expensive or difficult to manage. As a result, fiber connections to the home take months, if not years, to deploy. Terragraph was designed to address this last mile connectivity gap and deliver multi-gigabit performance wirelessly at a fraction of the cost of trenched fiber. You can think of it as extending fiber in the air. Terragraph is faster to deploy than traditional wired services because it builds upon existing fiber points by extending their capacity. This is done by mounting boxes on existing street signs and lampposts, which means it doesn't require costly right-of-way permissions. Terragraph's vision of a new wireless future began in 2015. This vision was twofold: to create a solution for last mile connectivity and organize a community to deploy it. To realize our vision, we worked with an ecosystem of partners, including chip makers like Qualcomm and a number of equipment manufacturers. Together, we designed and developed a family of equipment in the millimeter wave radio frequency spectrum. We even stress tested this on our Menlo Park campus to make sure the technology was mature enough to go to market. Between the advancement of millimeter wave technology and conversations with regulators to develop standards around this kind of deployment, everything came together at the right time. And the demand for gigabit connectivity has only accelerated with the pandemic, where fast and reliable internet is all the more critical. So how does Terragraph work? The network is made up of nodes that mount on street fixtures like lampposts and traffic lights. Millimeter wave signals have limited range, so these nodes are placed at 200 to 250 meter intervals. To create the network, you first need a fiber point of presence to tap into. We call this the POP site. In urban environments, this can be found on high rises like enterprise buildings. From there, you'll need both Terragraph distribution nodes and consumer nodes. Distribution nodes relay the signal from the POP site to other distribution nodes, connecting all together to form an area of coverage. Consumer nodes are mounted on the sides of buildings or on rooftops. These are then connected to things like an Ethernet cable or Wi-Fi router that brings connectivity into the premises. Now, you can imagine that any type of hardware placed outdoors will need to withstand the elements. Terragraph is designed to work in extreme conditions, whether that's rain, snow, wind, or heat. It can also withstand temperatures as low as minus 20 degrees Celsius and as high as 55 degrees Celsius. This is a testament to the engineering design that went into making such a product work under challenging conditions and in such a small footprint. And I want to go even deeper. The reference design for the distribution node is based on a centralized modular architecture that supports between 1 and 4 radio sectors that operate in the millimeter wave. We want each sector to have a 90-degree view such that 4 of them combined can make a 360-degree view so that collectively they can find another radio sector easily. The unit contains a single processor mounted on a digital board, which performs the routing function for all radio sectors. The centralized processor communicates with the individual radios. And depending on the unit's role, it also has a connector for a POP node if it's the main connecting agent. Making sure the nodes find each other to transmit their signal was a very hard problem to solve. In previous network configurations, people had to climb up poles and manually position wireless devices so that they lined up perfectly with one another. If you think about scale, you can see that can get really expensive fast. The beauty of Terragraph is that we figured out a way for the nodes to talk to each other immediately. The network figures itself out once deployed. After the nodes are all mounted, they work together to transmit multi-gigabit capacity to each other, creating a distributed network. But the crucial part of this network is what we call the resilient mesh. Each node has a built-in signal rerouting function to ensure the network is always stable, reliable, and high-performing. So let's see this in action so you can see what I mean. Say, for example, a building is under construction and some scaffolding obstructs the line of sight between 2 distribution nodes. The part of the network connected to these nodes would hypothetically break, cutting out the signal to homes and businesses. What the mesh network will do is automatically reroute the signal so that the connection remains stable without any service disruption. This happens within the space of a fraction of a second. Once the obstruction is removed, the signal will return to its original destination. This is really exciting technology that our team has refined for the past several years. It's been a long journey with Terragraph. What started as an early stage project within Facebook Connectivity is now being scaled and brought to market through our ecosystem of equipment manufacturers and service providers around the world. We licensed Terragraph for free to equipment manufacturers, and 5 of them are now selling their Terragraph-enabled hardware products. To date, these partners have shipped more than 30,000 Terragraph units to more than 100 service providers. And it's exciting to see these deployments continue to gain traction around the world. To give you a really specific example of how this works in Australia, I'd like to now turn it over to Stephen Cornish, founder of Pentanet.
Thanks, Yao. Hi, everyone. It's great to be here and share more about how we're using Terragraph to expand our network capability to deliver Pentanet Nexus, the next generation of high-speed internet here in Perth, Western Australia. To start, most of you probably don't know, but Perth is the most isolated capital city in the world. It's no secret that there's been a historical challenge to get fast and reliable internet service for our community, with Australia sadly coming in at number 53 on the Global Speed Test Index, and Perth having the second slowest internet speed of any capital city in our region. I started Pentanet in 2017 after frustration with available internet speeds at my own house when I was playing League of Legends. As a gamer, I needed a high-speed, low-latency solution, and there were very limited options in the market. Discovering fixed wireless technology was a game changer for me, and I could immediately see the massive potential for a private network here in Perth. So like anyone would, I sold my house and set about building my first transmission tower. Pentanet was built to deliver better connectivity supported by outstanding support and service for the people of Perth. Our network is quite extensive in Perth now, but traditional fixed wireless still eventually hits a ceiling of capability due to the line of sight constraints to the high up towers. We knew that we would one day need to eventually shift to a small cell deployment to give us the additional coverage we needed across the city to give more people access to our network. We also knew that Terragraph would be the best solution, and we're now in the process of converting our entire subscriber base to Cambium Networks hardware enabled by Terragraph onto what we call the Pentanet Nexus. We found Terragraph to be the best alternative to fibre, and we were amazed at how quickly we could get the network up and running and how easy it would be to scale. Being one of the more innovative carriers down under and gamers at heart, we also had the opportunity to become the operator of NVIDIA GeForce Now cloud gaming nationally. By always staying at the forefront of new and innovative ways to connect our users to next generation speeds, it allows us to adopt these future technologies that run on next generation networks. Our team at Pentanet is committed to delivering a new level of connectivity and internet access for our subscribers, designed to power the next generation of bandwidth heavy and latency sensitive applications. And really, we're all about innovative technology, connectivity, and gaming. So it's fun to be able to play with technology like Terragraph every day and be able to do what we love. Thanks for having us on today, and I'll now pass it back to Yao to close us out.
Thanks, Stephen. We're really excited to see Terragraph take off, and we're just getting started as our partners continue to bring Terragraph to other parts of the world, like Pentanet. Shrep kicked us off today by saying that we won't close the digital divide with business as usual. We need big, ambitious new technologies to change the way people get online. It needs to be faster, it needs to be more affordable, and it needs to work everywhere. And it's a complex problem with no silver bullet that requires the work of a whole ecosystem of participants around the world. What we showed you today is part of how we and our partners around the world plan to deliver on that kind of progress. It's based on doing what Facebook is really good at, inventing new technologies that work at a global scale. And as our colleagues build the foundational technologies for the metaverse, our work on connectivity is laying the foundations for a richer internet experience for everyone. On behalf of all the presenters, I'd like to thank everyone for tuning in today. We'll now open it up for Q&A.
Thanks, Yale. For our Q&A today, again, remember to please submit your questions using the Q&A tool at the bottom of the screen. Before we dive in, just a quick reminder that this presentation is on the record and our embargo is Thursday, October 7th at 7 a.m. Pacific time. We will now welcome back all of the panelists, and I will read the questions that have been submitted